Yes, good afternoon, students. And previous class we discussed about arithmetic, sequences and series. What is the definition of sequence and problems? Some applications on sequence are done by you people. Let us we continue with that, and then some more applications on that, as well as introduction of arithmetic progression. Some applications on that. In Here it is given 12th problem in exercise 9.1. It is mentioned that a1 is given as minus 1 and an is defined as an plus 1 by n, where n is greater than or equal to 2. For suppose here we need to find, write the first 5 terms of each of the following sequence and write its a series also. As you know, sequence is nothing but writing the term in a proper order by using following one rule. And say, a series means if you use plus symbol between those two terms, it is called a series. Whereas we find already a1 is given, that is why condition is given n is greater than or equal to 2. So if you take n is equals to 2, a2 become a2 plus 1 by n, n minus 1, it is a n minus 1. So a1 by 1, as we know n is equals to 2, n is equal to here. So as we know a1 by 2, that is equal minus 1 by 2. This is second term. If n is equals to 3, a is equals to a3 minus 1 by 3, that is equals to a2 by 3, that is equals to minus 1 by 2, minus 1 by 2 by 3, minus 1 by 2 into 3. As we know, this numerator become numerator for the term. So if you take n is equals to 4, a4 equals to a4 minus 1 term by 4, that is equals to a3 by 4, that is equals to minus 1 by 6 by 4, that is equal minus 1 by 6 into 4, that is equal minus 1 by 24. Let me take n is equals to 5, a5 equals to 5 minus 1 by 5, a4 by 5 minus 24 by 5, that is equal minus 1 by 24 into 5 minus 1 by 120. We have 5 terms in this manner. So now it's a sequence we can write as minus 1 first term, minus 1 by 2, minus 1 by 6, minus 1 by 24, minus 1 by 120, so on. It's series. Series means just the difference between series and sequence is just we will add a plus symbol for each term of students. So we can write minus 1 of minus 1 plus of minus 1 by 2 plus of minus 1 by 6 plus of minus 1 by 24 plus of minus 1 by 120. So we can write simply minus 1 by 2 minus 1 by 6 minus 1 by 24 minus 1 by 22 plus so on. Infinite series. It is an infinite series. If they mention particularly find the sum of first 5 terms, just we will add it. So once again I am repeating, students, already a1 value is given, condition n is greater than or equal to, an is defined in this manner. Put n is equal to, we get a2 value, put n is equal to 3, a3 value, put n is equal to 4, a4 value, put n is equal to 5, a5 value, write a sequence and series. This is the way to solve the problems on sequence when nth term is given, finding its a sequence as well as series, students. Let us we discuss one more problem and a few more problems, then after we'll discuss about arithmetic sequence also. So next problem, students. This is a brief explanation about 12th problem of this given exercise. Let us we discuss next problem of this exercise. Then 13th is given as, here it is given that a1 equals to a2 equals to 2. I mean already first two terms are given. An is defined as an minus 1 when n is greater than 2. Condition C, students, because n is greater than 2, already first two terms are given. So we need to find first 5 terms and it's a sequence as well as series. Now if n is equals to 3, because 2 terms already we know, So if you take A3 is equals to A3 minus 1 minus 1, A2 minus 1, that is 2 minus 1, that is equal to 1. If you take n is equals to 4, A4 is equals to A4 minus 1 which is A3 minus 1. A3 is 1, 1 minus 1, 0. This is fourth term. If you take n is equals to 5, A5 is equals to A5 minus 1 minus A4 minus 1, that is equals to 0 minus 1 minus 1. It is a decreasing sequence, students, if you observe. So we have first five terms, may write its a sequence with the given condition as well as series also. So its sequence we can write as 2 comma 2 comma 1 comma 0 comma minus 1, so on. And the series, its a series is just we add plus symbol 2 plus 2 plus 1 0 plus minus 1, so on, infinite series. So this is the way to solve the problems related to sequences when nth term is defined. But in this particular case, a1, a2 are given already. We need an is defined as a of n minus 1 minus 1 when n is greater than 2. Find the third term, fourth term, fifth term, write its sequence and series, students. This is the way to solve. Let me solve last problem of this exercise. Then after I'll explain briefly about arithmetic progression, and we will do the problems related to arithmetic sequence or arithmetic progression. Already I have learned about arithmetic sequences in previous class. Let us continue. Now you people are going to learn about Fibonacci series. Fibonacci series means arrangement of numbers. If you add first two terms, you will get third term. Sum of second, third term is fourth term. In that manner, that is called Fibonacci series. So we are discussing about Fibonacci series or Fibonacci sequence. So example 2, 3, 5, 8, 13, 21. First two terms, no issue, students. If you add first two terms, we get third term. These two terms, third. If you add second, third, fourth term. If you add third and fourth term, we'll get fifth term. If you add this, we'll get so on. This is called Fibonacci series. We have one problem related to that. Here, it is given a1, a2 are one fixed. An is defined as a minus 1, an minus 1 plus an minus 2. Condition n is greater than 2 because already two terms are given. Let us solve. So according to given condition, if n is equals to 3, because two terms are already defined, a3, and we need to find an plus 1 by an, where n is equal to 1, 2, 3, 4 and 5. That is why here we should find up to 6 students. So we have 3 minus 1, a3 minus 2, that is equal to a2 plus a1, 1 plus 1 equals to 2. This is third term. If you take n is equal to 4, a4 is equals to 4 minus 1, a4 minus 2, that is equal to a3 plus a2. As we know, a3 is 2 plus 1, that is 3. So we get fourth term as 3. If n is equals to 5, a5 is equals to 5 minus 1 plus 5 minus 2, as we know, a4 plus a3. a4 is 3 plus 2, 5. If n is equals to 6 students, a6 equals to a6 minus 1 plus a6 minus 2, that is equal to a5 plus a4. a5 we got as 5 plus 3, 8. So write this Fibonacci series, students. 1 comma 1 2 3 5 8, so on. 1 plus 1 2, 1 plus 2 3, 2 plus 3 5, 3 plus 5 8. This is Fibonacci series. Now we have to find this value. So while finding this value, little careful, students. If we need to find this value, if n is equal to 1, an plus 1 by an equals to a1 plus 1, a1, that is equal to a2 by a1, that is equal to 1 by 1. If you take n is equals to 2 directly, 2 plus 1 we know 3, a3 by a2, or else we can write 2 plus 1 by a2, a3 by a2. As we know, a3 is 2, a1 is 1 and I mean a2 is 1, so we got. Similarly, if n is equals to 3, we get a4 by a3 because 3 plus 1 4, so a fourth value is 3 by 2, so this is the value. If n is equals to 4, a5 by a4, fifth term we have 5 by 3. If n is equals to 5, students, we have a6 by a5. A6th value we have 8 by 5. This is the way to solve, students, Fibonacci numbers writing in this form, an plus 1 by an form. Yes, students, let me continue some more problems related to this. Yes, students, so this is the way to solve the problems related to sequences. So here we discussed a few problems based on Fibonacci series. This is one of the example of Fibonacci series, and we have done the problems, and we found the value of an plus 1 by an when n is equals to, where n equals to 1, 2, 3, 4, 5. That is why we found here a6 also, because we will get here a6 by a5 according to given condition. Let us we continue with arithmetic progression, students. So in sequences, already we have different type of sequences: arithmetic sequence, geometric sequence, harmonic sequence. But harmonic sequence is not there in our standard. Next class we will get. Let us we discuss about arithmetic sequence. Already you have I have known about arithmetic sequence, arrangement of numbers in a sequential order by adding a fixed number with its preceding term. Will get the term that is called arithmetic sequence. It is applicable one except first term. So in arithmetic sequence or arithmetic progression, simple form is AP. Terms are in the form of a plus d, a plus 2d, a plus 3d, so on, a plus of n minus d. Here a is called first term, a is called first term, and d is called as common difference. By difference between a2, I mean we can common difference. D is defined as a2 minus a1 or a3 minus a2, so on, an minus 1 minus an minus 2. And then after, this is a form of terms in an AP, and then here nth term, general term or nth term or last term of an AP is defined as a plus of n minus 1 into d. And then after, students, when n terms are given, to find sum of first n terms, we have a formula, that is sum of n terms Sn equals to n by 2 of 2a plus n minus 1 into d, where n is nth term. And when we know a nth value, a nth term, we can use, if you know last term, we can use a plus l. And arithmetic mean of b is defined as a plus c by 2. This is the way to solve general. So here arithmetic mean is defined as a plus c by 2. Already you people have known about average. That is nothing but arithmetic mean. These are all the concepts we will use while solving the problem, students. Exercise 9.2 and example problems do as a practicing problem. Let us we discuss few problems in exercise 9.2. Yes. So here, as we know, first term common difference, general term last term, and Sn value. And one more thing, we can find an, nth term of AP, when we know an, when if you know Sn, we can write an value as Sn minus Sn minus 1. when sum of n terms given. Let us we discuss problem, students, in 9.2. First one is given, find the sum of odd integers from 1 to 2001. Sum of 1 to 2001. Sum of odd integers. From is given, students, little careful. We can include the two extreme terms also. But what are odd integers we have between these? I mean, from 1 to 2001, 1, 3, 5, 7, so on, 2001. We have a value as 1. D value is defined as a2 minus a1, which is 2. And an nothing but last term is given 2001. By first we need to find n value, then after use this formula, because already last term and first term as we know. If you know n value, enough, students. We doesn't know n value, I mean number of odd integers. Let us we take n is equal to n equals to a plus n minus 1 into d is equals to 2001. A value as we know 1 plus n minus 1 of 2 is equals to 2001. N minus 1 of 2 is equals to 2001 minus 2. 1 is equal to 2000. N minus 1 is equals to 2000 by 2, that is equal to 1000 as we know. Then n is equals to 1000 plus 1, that is equal to 1001. So we need to find S1001, which is equals to 1001 by 2 of 2001 plus 2001 plus 2002. We get 2 ones are 2 1001s, which is 1001 into 1001. So we need to find the sum of these terms. This is the manner to find the sum of terms within the given limits. No, so if you multiply these two values, you will get the value, student, that is. So this is the sum of the odd integers between 1 and 2000, from 1 to 2001. But from is given means we should include extreme terms. If it is given between, we shouldn't include. So this is the way to solve, students. First you take a value, d value, find n value. Then after substitute in essence formula. You have one more model you can do as homework, students. This is the brief explanation about problems related to this. Let us we discuss one more problem, and next class we will continue with the students. So I'll just give you brief explanation about next problem, then you need to complete as homework. Here it is given that find the sum of all natural numbers lying between. It is given between. So there is a small difference from it is given and between given, between 100 to 1000, which are multiples are divisible by 5. Multiples of 5. So here it is given between, students. Previous problem from is given, so included, but it should not include 100 and 1000. So 105, 110, 115, so on 995. A is 105, D is A2 minus A1, that is 110 minus 105, which is 5. Substitute in this, and an or last term is given 995. So if you substitute, students, we get, and we will use the same formula, same procedure. So an equals to a plus of n minus 1, d is equal to 995. A is 105 plus n minus 1 into 5, 995. So n minus 1 of 5 is equals to 995 minus 1 of 5 equal to 0, 9, 8. n minus 1 is equals to 890 by 5, 5 ones are, 5 sevens are, 5 eights are. So n is equals to 179, and we'll put here yes, 179 is equals to 29 by 2 into a value 105 plus 995, 179 into 995, 1100 by 2 ones are, 2 fives are, 2 5 50s are. So 105, so 995 plus here it is 995 1100. So if you multiply those, you will get. I will conclude with this, students. If you have doubt, you can ask me next class. This is a brief explanation about the problems related to this problem. So we got so yes, 179, because 179 multiples are there. If you have any doubt regarding, you can ask me next class. I'm concluding with this, friends. Thank you.